Give a language model a word problem and something interesting happens. Getting the right answer isn't about knowing a fact. It's about not slipping on any of the steps in between. Miss one and the whole thing falls apart. That's exactly what GSM8K was built to probe. Cobbe and colleagues at OpenAI released it in 2021 as about 8,000 grade school math word problems, and it quietly became the standard test for whether a model can actually reason. Here's what makes it tick. Now, to see why GSM8K mattered, put it next to the kind of question it replaced. Plenty of older tests ask a single-step question. One calculation, one lookup, and you're done. The trouble is a model can often pattern match its way to the answer without genuinely reasoning, because there's only one move to make and nowhere for a mistake to hide. GSM8K flips that. Every problem is a short story that needs a chain of 2 to 8 arithmetic steps, the sort a bright middle schooler could handle. Because the steps depend on each other, a single slip anywhere breaks the whole answer, so faking your way through stops working. Let's walk one problem through start to finish so you can feel where models trip. First, the model reads a plain English word problem. Something like a shopkeeper buying crates, selling some, restocking the rest. Nothing exotic, just everyday arithmetic wrapped in a little story you have to parse carefully. Then it has to work through several steps in order. Add here, multiply there, carry a result forward into the next line. This is the part that separates real reasoning from a lucky guess, because each step feeds the one after it. Here's the catch. Any single slip anywhere along that chain quietly poisons everything downstream. Get step 3 wrong and steps 4 and 5 are built on sand, even if the model does them perfectly. There's no partial credit for good intentions. Finally, grading looks at only the final numeric answer. Match the number, you pass. Miss it, you fail. That clean, unforgiving check is what makes GSM8K so hard to fake and so easy to trust. So why did this little math set stay important for years? 3 ideas carry it. These word problems sound almost too simple, and that's the point. They need multi-step arithmetic, not memorized trivia, so a model can't lean on knowledge it's soaked up from the web to shortcut the reasoning. Because the steps chain together, GSM8K exposes whether a model reasons step by step or just pattern matches. That distinction is the whole ballgame, and few benchmarks isolate it as cleanly as this one does. And this is where chain of thought prompting first shined. Asking a model to show its work, line by line, sent GSM8K scores climbing dramatically, which turned this dataset into a favorite proving ground for reasoning research. Alright, let's lock in the 4 things worth remembering. GSM8K is about 8,000 grade school math word problems from Cobbe and colleagues at OpenAI, released in 2021. Each problem needs a chain of 2 to 8 arithmetic steps, so one slip anywhere breaks the final answer. Grading checks only the final number, which makes it clean, hard to fake, and a trustworthy signal of real reasoning. This benchmark is where chain of thought prompting first proved its worth, and top models now largely solve it, pushing the field toward harder math sets. Want more AI ideas explained without the jargon? That's exactly what we do over at Standarity.com. Come say hi.